Good afternoon. I'm sorry, this is my second recording. My first recording got deleted somehow from everywhere, so I'm recording it again. I am doing a review for the Nature paper, Consistent Increase in High Asia's Runoff Due to Increasing Glacier Melt and Precipitation. This paper is written by Emmer Zeel, who is a very famous water scientist, and I am Hira Sattar. This is the outline of my presentation. So due to the rapidly changing climate, global temperatures are rising at an alarming rate. According to IPCC, it is going to be 2 to 5 degrees Celsius hotter by the end of this century. Increasing temperatures as well as disturbed rainfall patterns are also going to affect the river flows around the world. Although this change is going to affect all of us, however, there are some areas who are more susceptible to negative impacts of climate change rather than others. The developed countries like Northern America, European countries, they are more resilient to the climate change, whereas some parts of Asia and Africa are more vulnerable. So the high mountains of Asia, consisting of Himalayas and Karakoram mountain ranges, have mainly glaciers and rivers originating from the mostly snow-fed rivers, as they depend on snowmelt on their runoff. These rivers in this region originate from the Tibetan Plateau, and a large population depends on their water for their livelihood. But because this region is not very developed, it lacks adequate gauge stations, especially in the upper Indus Basin. Therefore, there is poor quantification of water resources, which leads to lack of understanding of the hydrological regime. The climate projections also contain uncertainties, as different GCMs and RCMs provide with different estimations. Hence, it is required to estimate water availability in this area with higher accuracy. The main objective of this paper is to evaluate the impacts of climate change on water availability in Asia's high mountains. The specific objectives are to analyze historical and current runoff in 5 large river basins of Asia, to project future climate in the river basins, and to evaluate the impact of the changing climate on the runoff of the selected river basins. This is a set study area. It consists of 5 river basins: Upper Indus, Upper Ganges, Upper Brahmaputra, Upper Salween, and Upper Mekong. This study area does not contain the complete river basins, but only their upper portion, which are snow-fed. The methodological framework is as follows. The basin data, which includes the climate data, soil, water, and ice cover, it's put into a cryospheric hydrological model of 1 by 1 kilometer spatial resolution, and the model is calibrated for 10 years from 1998 to 2007. This is the objective 1 of the study. Then objective 2 of this study is to get the future climate projection data from CMIP5 website. They have used 4 GCMs and 2 RCPs 4.5 and RCP 8.5, and they used delta change approach for bias correction and estimated the future climate of 2050s. After that, the future projected climate is incorporated into the calibrated and validated model to estimate the future runoff. And then assessment of impact of climate change on the runoff is done, which is the final objective, objective number 3. These are the results: quantification of future hydrology in the 5 river basins. Here you can see some new names like Kabul, Ghagra, and Koshi. So they are the tributaries of the selected river basins. Kabul is tributary of Indus River Basin, whereas Ghagra and Koshi are the tributaries of Ganges River Basin. In this slide, this slide shows the main results of the research, and the red line shows the future discharge, whereas the blue line shows the current discharge. The annual runoff generated in Upper Indus Basin increases by 7 to 12% in 2000 from 2041 to 2050 with respect to the reference period. For rainfall runoff generated river basins like the Upper Ganges Basin, the future hydrology depends on the precipitation. In Brahmaputra, the overall increase in discharge is due to increase in precipitation as well, because they are mainly rainfall runoff generated river basins. However, the river basins like Indus, they are more snow-fed. So the snow parameter in those river basins are more. Similarly, the Salween and Mekong river basins are very similar in their changes with the future because the snow parameter is less and the rainfall is more. The pink line, the pink area at the bottom shows the base flow, and we can see that Salween and Mekong has more base flow because they have rainfall all over the year. They are more towards the tropical regions. So they have more base flow, which means that more water throughout the year. Whereas the river basins like Indus, they have very less rainfall, which shows very less base flow, which shows that there is a very large change between the wet and dry season. The hydrological responses in Upper Salween and Upper Mekong Basin are similar because their precipitation increases are fairly constant in all seasons, unlike the other river basins. So thank you very much.